Assalamu alaikum everyone. Welcome to my video tutorial on normal distribution. The normal distribution is a type of continuous probability distribution, which means that it relates to a continuous variable. So, for example, some variables that might be modeled by a normal distribution are the height of adult males in a particular country, or the time taken by students to complete a task, or the volume of coffee dispensed into a cup of a particular coffee machine, or the mass of babies at birth. So all of these are continuous variable, and the distribution that can be used to model such continuous probability distribution is the normal distribution. Now it describes the probability of this variable taking a particular range of values. So we cannot find, likewise in like we did in binomial distribution, we were able to find the probability of any particular value, for example probability of x equals to 2. But in this case, probability of any particular number is 0. So now we will be talking about the probability of finding a range, probability of finding a range. So probability, for example, probability of x is greater than x1 and less than x2. Now this is a normal distribution curve which is made by probability density function, but we are not going to go in that much detail because it's not required what is a probability density function. But this is the general shape of a normal distribution curve. So if you have a normal random variable, if your data is distributed normally, the data will follow this curve. Now ideally this curve is symmetric about the mean. Okay, it is symmetric about the mean. In a normal distribution, there are relatively few very small or few very large values at the end, with the bulk of the distribution being concentrated around the middle value. It is infinite in both direction. So as you can see over here, this is infinite in both direction. It has one peak at the center. It is continuous obviously, and the total area under this curve would be 1. So the area under this curve represent probability, and we know that the total probability of any random variable would be 1. So the area under this curve is equals to 1. Okay. Now 95% of the value lie within approximately 2 standard deviation of the mean. I'll discuss this in the next slide as well. As you can see over here, if you go 2 standard deviation away from the mean, that's 95% of the data, which means that the probability is 0, roughly 0.95. And if you go 3 standard deviation away from the mean, now going 3 standard deviation away from the mean means going 3 standard deviation above the mean or below the mean. So this entire region is 99%, which is 0.99 roughly. So how do we describe a normal variable? We say x follows a normal distribution. The parameters of a normal distribution are mu and sigma square. Let me correct this. There's a typo over here. It's sigma square. Okay, so let me rewrite this. X follows a normal distribution with mean mu and sigma square. And we just discussed that the probability of any particular value in a normal distribution is 0 because the area of a single line is 0. Okay. Okay, so approximately 68% of the distribution lies within 1 standard deviation of the mean, which means that if this is your mean at the center, and within 1 standard deviation means either above 1 standard deviation above the mean, which is mu plus sigma, or 1 standard deviation below the mean, which is mu minus sigma, and the total area or the probability within 1 standard deviation of the mean is calculated to be approximately 68%. Similarly, if the data is approximately 2 standard deviation above the 2 standard deviation of the mean, which is 2 standard deviation above and 2 standard deviation below, so the area or the probability of this region is approximately 95%. And if it is 3 standard deviation about the mean, which means 3 standard deviation above and 3 standard deviation below, so the area is roughly 99.7%. But we won't be just using these approximations, we would be calculating the exact probabilities using the normal distribution curve. Now let's look at what happens when your mean is changed or when your standard deviation is altered. So when the mean is altered, for example, there are 3 distributions. X follows a normal distribution with mean 0 and sigma square is 1 square. So variance is basically 1 square and the standard deviation is 1. And you have another distribution with mean 4 and half square and mean 50 and 2 square, which means, okay, now how would the graph behave? How would the curve be differently for all these 3 distribution? The mean is 0, which means this, okay. Now if you have a mean of 4, then this means that the entire curve would be shifted towards right, toward 4 units. If it is mean is 50, it will be shifted further right. So this means that changes in the mean alter the position of the curve along the x-axis. However, changes in the standard deviation alter the spread of the curve about the mean, which means if the standard deviation was 1 in this case, then let's say this is the shape. Now if the standard deviation is decreased, it's half, then the spread would also be decreased. And since the spread is decreasing, the peak would be raised up because the total area needs to be 1, right? Similarly, if the spread is increased, the standard deviation is increased, then the spread would also be increased. Alright, so probabilities are given by areas under the normal curve. So if you have x1, if you are being asked to find probability of x less than x1 and x1 is below the mean, which means x1 is over here, so this is the area that we are looking at. If you are asked to find the probability of x greater than x2 and you know that x2 lies above the mean, so this is the region, the probability would be given up by this area. And if you are being asked to find probability of x greater than x1 and less than x2, and you already know that x1 is below the mean and x2 is above the mean, so we are looking at the area between them. Okay, and the area towards the left of the mean is 0.5 and towards the right of the mean is also 0.5, and we have discussed that normal distribution curve are symmetrical. Okay, another important thing that I would like to highlight over here is that probability of x less than x1 is same as probability of x less than equal to x1. Why? Because probability of x equal to x1 is 0. So since this probability is 0, this means that probability of x less than x1 is same as probability of x less than equal to x1. And similarly over here as well, probability of x greater than x2 would be same as probability of x greater than equal to x2. Before beginning the question, you should have a clear idea on how to use the normal distribution curve. Now this is a normal distribution curve which is provided in your exam. In the extreme left column you have all the z values up to 1 decimal places. This is the second decimal place of the z value and this is the third decimal place. So for example, probability of z less than 0.111 would be 0.5438 plus 0.0004. I'll explain you this in detail, but few pointers over here that only positive z values are recorded over here, and the probability is for the positive z values. This central region gives you the probabilities. So if you look at the table, it goes up to 2.9 z value, Okay, and these are the probabilities written in the center. The minimum probability over here is 0.5. Acha. So what I can do is, this region, since this region, if z lies over here, acha, we can only use this when we have standardized our normal distribution question, which means standardizing means that you have make sure that the mean is 0. Now I'll be dividing my normal distribution curve in two parts for my convenience. I'll be calling the area that is greater than 50% to be the body area, and the area that is lesser than that have a probability of lesser than 0.5 is the tail area. Now let me give you some example. Let's say I need to calculate the probability of z less than 0.16. So this means that I'll go, the first decimal place is 0.1 and then 6. So z less than 0.16 means z is greater than 0. Okay, it's a positive z value, which means definitely it would be lying over here. You want to find the probability of z less than 0.16, which is the body area, so region to the left, and you can have the body area from here 0.16, so the probability comes out to be 0.5636. Now if you were asked to find the probability of z less than 0.345, this is 3 decimal places for the z value. So again, 0.345 is greater than 0, which means it's a positive z value, and you want to find the probability of z less than 0.345. So again, you are interested in finding the body area, all of this area, and your table has probabilities for the body area. So 0.345, 0.34. Okay, so right now the probability is 0.6331, and the last digit is 5, which means this one. So this means that you will have to add okay, so 0.6331, and you will have to add 0.0019. This digit is added into this to this value, so the probability comes out to be 0.6350. Okay, now what do we do if we have a z value that is even greater than 3 decimal places? For example, probability of z less than 1.3469, so you will round this up to 3 decimal places. So probability of z less than 1.347, and then you will find the probability in the similar way. Okay, now let's say if the question is to find the probability of z greater than 0.16. So we know that the mean is 0. 0.16 would lie over here. First of all, now if you want to use the table will give us the body area, which is this, and we just now find that the probability is 0.5636. Okay, in order to find probability of z greater than 0.16, which means we are interested in tail area. So this would be calculated by doing 1 minus 0.5636, which comes out to be 5636, which comes out to be 0.4364. That is your probability for the tail area, and this is how we will be solving questions. Now there are some probabilities. We will call those critical values. For example, 0.75. So probability of, if you have a probability of 0.75 or 0.9 or 0.9, and you want to find the z value, corresponding z value, so they are separately mentioned in this table. Okay, so let's have a discussion on standard normal variable. The standard normal variable is given the special name z rather than x. So if x was defined as time, that is our main variable, but we will standardize it in terms of z so that we can use the table. Now in this particular example, the z follows a normal distribution with mean 0 and variance 1, and you are being asked to find the probability of z less than 0.85. So your normal distribution curve would look something like this, where your mean is 0, this value is 0.85, and you want to find the probability of z less than 0.85, which means you need to find the body area. Now in order to find, in order this is 0.85, now we need to find the probability. So for probability, what we are going to do is we will use our table, and at 0.85, at a z value of 0.85, 0.8, the probability comes out to be 0.8023. So this area is 0.8023. So probability of z less than 0.85 would be 0.8023. Now if we are asked to find the probability of z greater than 0.85, this is 0, this is 0.85, this time we are asked to find probability greater than 0.85, which is the tail area. So I can't use my table to find the probability of a tail area, so I'll do this in two steps. First, I'll find the probability of z less than 0.85 from the table, which we just found to be 0.8023, and then I'll find the probability of z greater than, so probability of z greater than 0.85 would be 1 minus the probability of z less than 0.85. So 1 minus z, the probability of z less than 0.85 was 0.8023, and the probability comes out to be 0.1977. That's the probability for this region, for the probability of z greater than 0.85. So guys, now you will notice that the table starts at z equals to 0, so and gives values for positive values of z, so it will give you probabilities for positive values of z. But when z is negative, you need to use the fact that the normal curve is symmetrical. So let's say I need to find the probability of z less than minus a. So if z is lesser than 0, it will be a negative number, and you want to find the probability of z less than minus a, which is this region. You need to find this probability. So this region, since the normal distribution curve is symmetrical, the area of the curve for probability of z less than minus a would be same as for probability of z greater than a. So what we will do is we will make the exact same shape over here with for positive a value, and we can use the table to find the probability of z less than a, and then we will subtract the answer of this probability from 1 to get this area. This area is exactly similar to this area. Similarly, if you were asked to find the probability of z greater than minus a, which means we are concerned about this area, this body area. Now in order to find this entire area, since we can't use a table for negative z value, we will reflect it and we will say, okay, let's find the area for positive a value. So we can easily use a table to find the probability of this region. Once we have found the probability of this region, then the probability of this region would be same. So this is how you will attempt questions for negative z values. Now I have an example for you. Let's say we have this example. The first one is probability of z less than 1.377. So the mean is 0. 1.377 is this side, 1.377. Now I'll have to use my table to find the I've been asked to find the probability of z less than 1.377, which means this is this body area. Now I'll use my table to find the probability of z less than 1.377. So I'll go on my table, 1.377, 1.37, and the seventh value is 11. So the probability would be 0.9147 plus 0.0011, and the probability comes out to be 0.9158. So this area 0.9158. Okay. In the second part, they are saying to find the probability of z greater than minus 1.377. So minus 1.377 is this region, and I want to find the probability of this region, this body area, which is the entire this area. Now since it's a negative z value, I cannot use my table directly. I'll have to use the concept of symmetry and find the probability of z less than 1.377. This body area would have the same area when I'll use 1.377, and this area is same as this area. So if I'm able to find this value, which I just found in part 1, 0.9158, so the probability of z greater than minus 1.377 would be 0.9158. Alright. Now in the third part, this was the second part. For the third part, you want to find probability of z greater than 1.377. Now this is simple. We just discussed this. This is 0, 1.377. You already have the body area, which is 0.9158, and this time you need to find the probability of z greater than 1.377. So 1 minus the way you will find this probability, this tail area would be 1 minus 0.9158. So you get 0.0842. That's the probability for z greater than 1.377. Now in the last part, you are being asked to find the probability of z less than minus 1.377. So this is 0, minus 1.377, but this time you are being asked to find this region, the tail area. Now since it's for the negative z value, I cannot have the value of the probability from the table. So what I'll do is I'll reflect this, and I'll say that there is an equivalent area for the positive z value. So 1.377, I'll say that this area is equal to this area, and I already have the answer for this area, which I just calculated to be 0.0842 over here. So this area would also be 0.0842. So I can say that probability of z less than minus 1.377 is same as 0.0842. Okay, so to use a table for any normal variable x with mean mu and variance sigma square, the variable is standardized, which means that the variable x is converted into a new variable now, which is z. And in this slide we will discuss how to convert or how to standardize a normal variable into a standard normal variable. So if you have a normal distribution, if x is normally distributed with mean mu and sigma square is the variance, so mean is over here. Now if mu plus sigma means one standard deviation above the mean, mu minus sigma means one standard deviation below the mean, and so on and so forth. So what we'll do is we subtract mu from every value of x. So mu minus mu 0, mu plus sigma minus mu 1 sigma, mu plus 2 sigma minus mu 2 sigma, and mu minus sigma minus mu is minus sigma. Now the third step would be to divide these values by sigma. So mu divided by sigma, sigma divided by sigma is 1, 2 sigma divided by sigma is 2, 3 sigma divided by sigma is 3, and so on. Now what happens is we have converted our normal distribution curve into z values. These are z values, these are corresponding z values. So the value of z equals to 1 correspond to a value of x that is one standard deviation away from the mean. The value of 2 correspond to the value of x that is 2 standard deviation away from the mean. So z is calculated through this formula, x minus mu over sigma, where z is normally distributed with mean 0 and standard and variance as 1. Every normal random variable x is to be converted to a standard normal random variable z in order to refer to the standard table for probabilities. So the table which we just saw previously was for standard normal z values, and now you will have to calculate z values through this expression. So let's look at this example. In this example, metal strips are produced by a machine. The length of strips follow a normal distribution with mean 150 and standard deviation 10 cm. So our x is the length in centimeter of a metal strip. Length of a metal strip. And this x follows a normal distribution with mean 150 and standard deviation is 10, so variance would be recorded as 10 square. You are supposed to find the probability that a randomly chosen strip from a production line has a length less than 165. So in part 1 you need to find probability that x is less than 165. So the first step is to convert. Okay, let me draw a normal distribution curve for you. This is a normal distribution curve, this is not a standard normal distribution curve. So the mean is 150. Obviously 165 would be towards the right, and you want to find this probability. So the first step is to convert the value of 165 into z value. So z would be x minus mu over sigma, 165 minus 150 over 10. So this comes out to be 1.5. So if I were to draw a standard normal distribution curve where the mean is 0, the corresponding value of 165 would be 1.5. So finding the probability of x less than 165 is same as saying probability of z less than 1.5, which is this region. Now I can use my table to find the probability. So probability of z less than 1.5 would be 1.5, 0.9332. So the probability would be 0.9332 and in three significant figures 0.933. Now the second part says find the probability between 127.5 and 139.2. Now the way you will attempt this part is, it's always better to draw these curves to have a better perspective of the question. The mean is 150. We have a value of 127.5, so which will be towards the left, and then we have another value which is 139.5. okay, now I need to find this region. Now both values are towards the left, so their corresponding z values would be negative. So let's find what are the corresponding z values. So the corresponding z value of 127.5 would be 127.5 minus 150 over 10, which is negative 2.25, and the corresponding value of 139.5 would be minus 1.08. So these values are minus 2.25 and negative 1.08. Now we know that we cannot use our table directly to find the probabilities for negative z values. We will have to reflect it. So the shortest way to do this is to read the probability of the body area at z value of 2.25. This will give you this region. Okay, so the table will always give you the body area, that is the area greater than 50%. So you will go to your table and read the probability at positive 2.25. so the value that you will get is 0.9878, and then you will read the probability at positive 1.08. so the answer would be 0.8599. Now in order to find this region, probability of z greater than minus 2.25 and less than negative 1.08 would be the difference of the two probabilities. So 0.9878 minus 0.8599, and the probability comes out to be 0.1279. so according to three significant figures, 0.128 is the probability of z greater than minus 2.25 and less than minus 1.08, which is same as probability of x greater than 127.5 and less than 139.2. Now for the third part says find the probability that deviates from the mean by more than 28 centimeter. So this means that we are looking at a region which deviates by more than 28 centimeter. So the mean was 150. Now the deviation of 28 centimeter can be both ways, towards the left as well as towards the right. So if you subtract 28 from 150, you get 122, and if you add 28 to 150, you get 178. You want to find the region that deviates more than by 28. So this region would deviate more than by 28, and this region would deviate more than by 28. Okay, so the way you are going to approach this question is you will find the z values. So we know that the corresponding z value for 150 would be 0, and using the same formula x minus mu over sigma, the z value for 122 can be calculated as negative 2.8 and this as 2.8. Notice that the two z values are equal, which means this area and this area is also equal. Remember, we established this fact that the normal distribution curve is symmetrical. So if these two areas are equal, then definitely this area and this area would also be equal. Alright, so we want to find probability of x less than 122 or x greater than 178. So what you can do is you can first find the probability of this region, and then you can subtract the answer from 1 to get the blue shaded region. One way is this. So first find probability of x greater than 122 and less than 178. Now the way I would be solving this type of question is I'll first find the probability at a z value of 2.8, which would be this, right? And I know that this region is 50%, so the probability of this region is 0.5. So if you try to find the probability at 2.8 z value, you will get 0.9974. okay, now you will subtract 0.5 from 0.9974, then you will get this area, and then you can multiply it by 2 to get the region because they are similar. 0.9974 minus 0.5 times 2, so you get 0.9948. Or the other approach that you could have taken is you found the probability at 2.8, and you know that this probability would also be the same, so you can double them, but this probability would be exceeding 1. So by using the property of this figure, you can subtract it from 1 and still you will get the same answer, whichever method you find it convenient. But this isn't the final answer. We want to find this region, the blue one, which represent the deviation of by more than 28. The red region represent the deviation within 28. Okay, so we want to find probability of x greater than 1, x less than 122 or x greater than 178. So once we have this central region, what we can do is, in order to find probability of x less than 122 or x greater than 178, we can subtract this answer from 1, so that the leftover answer will be for 0.0052. The leftover answer would be for this blue region. Okay, so you could also be asked to find z when the probability is given. So for example, in this question, z follows a normal distribution with mean 0 and variance 1. You want to find probability of z less than, you want to find a where probability of z less than a is 0.9693. So this means that if I draw a standard normal distribution curve with mean 0, first of all I'll have to locate a by the help of this probability and this sign. They are saying that z lies at a place. Okay, so they are saying that z is less than a, so a should be lying. The first thing that you need to decide is whether a is lying towards the right of 0 or towards the left of 0. And in this case, obviously it would be lying towards, A would be lying towards right, such that the probability that Z is less than A is 96.93%, 0.9693. Okay, so this sign is basically the arrow. Z less than A is 96.93, so obviously it is the body area. Now you need to go to your table and do the reverse calculation. 0.9693 is the probability. So in this table you will be looking for 0.9693 in the probability region, or the closest value. So 0.9693. Okay, so here we have the probability. Now we'll see at which Z value was it occurring. It's occurring at 1.87. So 1.87 is our Z value. So 1.A has a value of 1.87 for the first example, and it will be positive 1.87 because we established this that A is towards the right of 0. As for part 2, probability of Z greater than A is 0.3802. Okay, so if you draw this standard normal distribution curve, mean is 0. Now A should be, you need, by considering this sign and the probability, you need to decide where is A lying. So A is lying at a place where Z greater than A is just 0.3802. So we have been given a tail area, so the value of A should be here, such that the probability of Z greater than A, which is the tail area, is just 0.3802. Now we know that we cannot have the Z value of a tail area corresponding to a tail area from the table. So what we'll do is we'll subtract 0.3802 from 1 to get this body area. So 1 minus 0.3802 gives you 6198, and now you can refer to your table and you can read the Z value at 0.6198. So we'll be going to our table and we'll read the value at 0.6198. So 0.6198. So we have 0.6179, and we know that we have to add 19 to make it 0.6198. So the Z value, the corresponding Z value is 0.3, 0 and 5. So the Z value comes out to be, for this part, the Z value comes out to be 0.305. Now the third part says find the probability of Z greater than A equals to 0.7367. You need to find the value of A, not the probability. The probability is given. So let's draw this curve again. Now A should be placed in such a way that the area above the value A must be the body area. So A would be towards the left, such that the area above A, this means above A, is 0.7367. So you can use your table directly for the body area. So 0.7367 is the probability. 0.7367. Let's find the probability. 0.7357, and you will have to add 10 to make it 0.7367. So it's occurring at 0.633. So 0.633. But as per our sketch, it's negative 0.633. A is negative 0.633 because it is towards the left of 0. Now finally the last part, which says probability of Z less than A is 0.0793. So we can see that this area is the tail area and Z less than A. So A should be placed in such a region such that the area below it is just the tail area. So A would be towards the left of 0. So obviously Z value would be negative, but we cannot have the probability of the tail area from the table. So we will take the body area. So 1 minus 0.0793 is 0.927, and you will refer to your table to find the probability at find the value of Z for 0.9207. So 0.9207. Here we go. So it is occurring at a value of 1.41. Okay, 1.41. But this is negative 1.41 as A is towards the left. So the value of A in this case is negative 1.41. Okay, so now let's look at question in which you have to find mu or sigma or both. So there will be some questions जिसमें mu and sigma would be unknown to you. Alright. So let's look at this example. The length of Paulo's lunch break follows a normal distribution with mean mu and standard deviation of, so variance is 5 square. What is x representing over here? It is the time in minutes that the lunch break lasts. Okay, now they are saying that on one day in 4 on average his lunch break lasts for more than 52 minutes. So you can draw a normal distribution curve. The mean is mu, and we know that on one day in 4 on average his lunch break lasts for more than 52 minutes. So more than 52 minutes, the probability that it lasts more than 52 minutes is 1 over 4. 1 day in 4 means 1 over 4 is the probability, which is equivalent to 0.25. So where do you think I should mark 52? Should it be towards the right of mu or towards the left? Well, to decide that, you will look at the probability. It's a tail area and they are saying that x greater than 52. So if 52 is here, definitely this is the tail area which is less than 50%, and this probability is 0.25. Okay, so this means that the body area would be 0.75 then. Now these are the x values. For z value, you will use that transformation, which is z equals to x minus mu over sigma, and 52 minus mu over sigma would be equal to the z value. But we don't have the mu and we don't have the z value, so we cannot calculate the z value first. Okay, so using the probability of the body area, we will have to do the reverse working and find the z value at 0.75. So at the probability of 0.75, you can use this small table beneath. You can see that the z value is 0.674. So the corresponding z value is 0.674 for 52. Okay, so now we know this. We know that z is equal to x minus mu over sigma. Z value comes out to be 0.674. The value of x was 52. The mu is unknown and sigma is given to in the question as 5. So you can cross multiply and solve for mu and you get roughly 48.6. So this is how you can find the unknown value of mu. Alright, in the second part they are saying find the probability that Paulo's lunch break lasts for between 40 and 46 minutes on every one of the next 4 days. Okay, so now we know the mean, that is 48.6. I'll do the working over here. In the second part, we know that x follows a normal distribution with mean 48.63 to be precise and 5 square. Now the question is asking that find the probability that x is greater than 40. You will just first you will find it for the for 1 day. You want to find the probability that on any particular day his lunch break lasts between 40 and 46. First you will find it for one particular day and then we will find it for the next 4 days. So you go for the same strategy. The mean is 48.63. So the value of 40 is over here and the value of 46 is also here. So we are looking at the region between them. Okay, now you can use your transformation, that is x minus mu over sigma, to calculate the z values. These were x values. The z value would be, for the mean it's always 0. The z value for corresponding to 46, you can calculate it through this x minus mu over sigma. So I'll just write down the value. It's negative 0.526 and it makes sense because it's a value less than mu, so the z value would be negative. So this is for this, and the value z value for 40 would be minus 1.726. So finding the probability of x greater than 40 and less than 46 is same as saying finding the probability of z greater than minus 1.726 and less than negative 0.526. Alright, now you can use the same strategy that we did in the previous slide to find the area between. So I'll just give you a brief explanation. You can ignore the negative sign and find this body area, and you can ignore the negative sign and you can find the probability at positive 0.526. This will be this area, and then you can subtract to get this region. Alright, so the probability at negative 1.726, well, we will ignore the negative sign, and the body area comes out to be, this body area comes out to be from the table 0.9578, and this body area comes out to be 0.7005. Okay, now in order to find the region between them, we will subtract the two values and you get 0.257. Okay, now this is the probability that on any particular day his lunch break lasts between 40 and 46 minutes. But the question is saying find the probability that his lunch break lasts between 40 and 46 minutes for the next 4 days. So for the next 4 days, you need to find probability that is lunch break lasts between 40 and 46 for next 4 days. So for that, you know that the probability that his lunch break lasts for between 40 and 46 on any particular day is 0.257. So for the next 4 days, you want that consecutively this thing can happen. So on the first day, his lunch break lasts for more than between 40 and 46, and then the next day also, then the next day also, and then the next day also. So 0.257 times 0.257 times 0.257 times 0.257, which in shorter way is same as saying 0.257 raised to the power 4, and the answer is 0.00438 according to three significant figures. Now this brings us to the last topic of this chapter, that is the normal approximation to a binomial distribution question. Now in cases where you have a binomial distribution question which with a lot of number of trials, and it's not feasible for you to calculate the probabilities for the individual probabilities, and the working would be very very tedious. So there is a approach that is known as normal approximation to a binomial distribution question. What happens is that if the value of n, now we are referring to the binomial distribution with n trials and p was the probability of success. So statisticians have concluded that if the product of np is greater than 5 and nq is greater than 5, then your binomial distribution is more symmetrical to a normal distribution question. Okay, so I'll just read this out. In case of a binomial process having large number of trials, the binomial formula for computing probabilities becomes ineffective or tedious, and therefore a normal approximation can be used to estimate the probabilities. So conditions for normal approximation is that, like, you cannot just apply normal approximation to a binomial distribution question. You need to check whether the product of np is greater than 5 or nq is greater than 5. If this satisfies, then you can go for normal approximation, because your curve because your distribution would be symmetrical now. So approximation gets better with higher number of trials. So as the value of n will increase, it will resemble more to a normal distribution curve. Now when we are converting our distribution from a discrete distribution, which was a binomial, towards a normal distribution, we need to apply a continuity correction of plus minus 0.5. So this means that if we have 5, we have a value of 5, let's say, okay, probability of x less than equal to 5. Now you have to apply continuity correction, and the boundaries of 5 would be 5.5 and 4.5. You want x less than equal to 5, which means that 5 is included. So you will have to decide which boundary to take, either to take less than 4.5 or less than 5.5. You will select the boundary which could also cover the region for 5. So in this case it will be less than 5.5, क्योंकि आप चाहते हैं कि ये 5 वाली भी probability cover हो जाए. ठीक है. So the continuity correction for less than equal to 5 would be 5.5, but for less than 5 you don't want 5 to be included, so you'll just go for 4.5. So the continuity correction would be 4.5, probability of x less than 4.5, and then you will go to your table and find the probability of 4.5. चलिए let's look at this. Probability of x greater than equal to 8. Greater than equal to 8 का मतलब है that the boundaries are 7.5 and 8.5. Now we want 8 to be included, so, and we want the region above it, so we will take the probability from x greater than 7.5. Okay, and if we don't want 8 to be included, we will take the continuity correction of 8 to be probability of x greater than 8.5. Okay, now if you have probability of x greater than equal to 2 and less than equal to 7. So greater than equal to 2 and less than equal to 7. So the boundary for 2 would be 1.5 and 2.5, and the boundary for 7 would be 6.5 and 7.5. You want, okay, it's greater than equal to 2, which means you want 2, so you will take greater than 1.5, and you want 7 to be included but less than, so instead of 6.5 you will take 7.5. So that would be your continuity correction. And now you can also try out, okay, why does this becomes this. The continuity correction of x greater than 2 and less than 7 means that you don't want 2 and you don't want 7, so you will take 2.5, greater than 2.5 region and less than 6.5. So this is how you will do continuity correction. So let's look at this example. A garden shop sells polyanthrous plants in boxes, each box containing the same number of plants. The number of plants per box which produce yellow flower has a binomial distribution with mean 11 and variance 4.95. So basically in this case, x, your discrete random variable, is the number of plants producing yellow flowers, number of plants producing yellow flowers, and x follows a binomial distribution with n trials and p is the probability of success. आपको ये पता है कि mean जो है, the mean is 11, and in a binomial distribution mean is the product of np, and variance is given to you as 4.95. So variance is npq, which is 4.95. Now you can solve these two equations simultaneously and get the values of p and q. So you will make p the subject, so it will be 11 upon n. Substitute it in the next equation. You need to remember that q is equal to 1 minus p. So when you solve these two equations, you get n as 20 and p as 0.55. These are your results. So the distribution is that x follows a binomial distribution with 20 number of plants, and the probability that a plant will be producing yellow flower is 0.55. In the next part they are saying find the probability that a box contains exactly 12 plants which produce yellow flowers. So out of 20 we want to find the probability that exactly 12 produces yellow flowers. Okay, so it's simply 20 seed 12, and the probability of success is 0.55 raised to the power 12 and 0.45 raised to the power of 8. I'm doing the working directly because I expect you to have watched my previous video on binomial distribution. So this is a binomial distribution question, and the answer comes out to be 0.1623, which rounded up to is 0.162. So that's the probability. Now in the next part they are saying another garden shop sells polyanthus plants in boxes of 100. The shop's advertisement states that the probability of any polyanthus plant producing a pink flower this time is 0.3. Use a suitable approximation. So we will just check which suitable approximation are they talking about to find the probability that a box contains fewer than 35 plants which produce pink flower. Now why is there a need for approximation? We will first check, is the product of np greater than 5 and nq greater than 5? If it is, then we will go for normal approximation, because we want to find the probability of x less than 35. So meaning it's tedious for you to calculate probability of 0, 1, 2, 3 up to 35, up to 34. So it's better if this we will be using suitable approximation, which is the normal approximation. Now I'll show you the working for this. So for part 3, let me replace my variable y is the number of plants. Well, I have just used y, you can use anything over here. जैसे कि वहाँ पे x यूज़ करते थे, यहाँ पे मैं y यूज़ कर रहा हूँ. Y is the number of plants producing pink flower in a box of 100. You need to understand the question. So this time y will follow a binomial distribution. How many boxes we have? We have 100 boxes, and the probability that you get a pink flower in a box is 0.3, that is given to you. Now since we need to use a normal approximation, we will check for the validity of normal approximation, and for the validity we need to check is the product of np greater than 5 and nq greater than 5. So np 100 times 0.3 is 30, which is greater than 5, and nq, which is 100 times 0.7, which is 70, which is also greater than 5. So we can go for normal approximation. Now converting it to a normal distribution, y follows a normal distribution. We need normal distribution parameters, which are mean. So mean is np, which is 30, and sigma square, which is the variance, is equal to npq. So 100 times 100 times 0.3 times 0.7. Okay, so then whatever the value comes, you need to take square root, and it comes out to be square root 21. So the mean is 30, and the standard deviation is root 21, so the variance would be 21. Now the question says that you need to find the probability of x less than 35. See, here is the catch. Probability of x less than 35 means, now you need to understand that your initial data was a discrete data and you are using normal approximation, which is used for continuous distribution. So you need to perform a continuity correction, and probability of x less than 35 would be, probability of y less than 35, y less than 35 y less than 35 would be same as probability of y. The boundaries of 35 are 34.5 and 35.5. You don't want 35, you want region lesser than 35, so you will not include 35. So y is less than 34.5. Now probability of y less than 34.5, you need to find the z value corresponding to 34.5. So you will calculate the z value through this 34.5 minus mu, which is 30, over sigma, which is root 21. So you get 0.9819. So this is same as saying z less than 0.9819. It's always better to draw a rough sketch. The mean is 30, 34.5 is this value, and you need to find this region. Okay, so this probability needs to be found. So the z value is 0.9819, and you can use your table to find the probability, which is 0.8370, which according to 3 significant figure would be 0.837. This brings us to the end of this chapter. I hope these videos were really helpful for you. Thank you.